Hi everybody, today we're looking at relations and functions, and in particular we want to think about the difference between the two. So to start our look at that, we're going to think about a relation first of all, and it's simply just a set of points. So I could have points, so say 2, 4, 3, 7 and 9, 14. Here's a set of points, and so that's a relation. Now a relation also though could have an infinite number of points. So if I was to draw a graph, here's my Cartesian plane, and my graph could look something like this. So I could start there, go up and loop around, and then it could go off, and it would be an infinite number of points. Now that's still a relation because it is a set of points. There's just lots of points. Or an infinite number really. So if we then want to think about the domain, it's just a set of all x coordinates of these points, and sometimes that's called the input values, because with a relation or a function you can input values and then you get output values, which we'll talk about in a bit more detail. So if I was to take my 3 points above, the input values or the domain would be 2, 3 and 9. Now if it's the relation that I drew, well that extends on forever in both directions. So if we have a look here, it's taking all the values out this way and all the values out that way. So the domain for my graph that I drew, or the relation that I drew, would be x in the reals. Now what that means is that x, well that's my domain values or my input values, is, now this little symbol here means in, and then this r means a set of all real numbers. So what we're saying here is that my domain values are all the real numbers, no real number excluded. The next thing we want to think about though is the range. Now the range of a relation is a set of all y coordinates, and they can be output values, or they can be called output values, or they can be called the image of a particular x value. So for my range, for those set of points I had, that my range was 4, 7 and 14. For the graph that I drew, well that extended up forever and down forever, so again in this case it would take all real values. Now that's a relation and the domain and range of a relation. And so now we get to think about a function. So a function is a relation, so it's a type of relation. But there's two key conditions. First of all, every value in the domain must have an associated value in the range, and every value in the domain can only have one associated value in the range. So we'll look at some examples to explain this. But first of all, let's just talk about notation. So for a function, often the notation we use is y equals f of x, or v of t, or c of n, or anything really, where the first letter represents the function, to just differentiate it between, so we can talk about different functions, and the letter in the brackets denotes the variable used. Now in a lot of functions you would have seen up to now, that variable in the brackets would be x. But there'll be a lot of cases in the course where we use different variables, and so you're going to have to get used to that. And we say that y is equal to these functions because the y coordinate of the points are equal to the values of the function. So whatever the function equals at a particular point forms the y coordinate of that point. Okay, so again we're going to consider a set of points. Going to be slightly different. So let's say 2, 4, 3, 7, so the first 2 points are the same as what we had before, but then we're going to have 4, 8 and 4, 9. So that's a relation because it's a set of points, but it's not a function. And it's not a function because the x value 4 has 2 y values. So why isn't that a function? Well, what did we say before? What was our definition? Well, our definition said every value in the domain can only have one associated value in the range. Now, our value in our domain is 4, but that has two values in our range, 8 and 9. And so this relation is not a function. Okay, consider a function mapping from values in the domain to values in the range. So here's where we draw a diagram which can help us. And you'll see this diagram a number of times. So what I do is I represent my range, my domain. So here's my domain, call that D for domain, and here's my range. And we could draw values in the domain and their associated values in the range. So for example, 1 might map to 7. So the associated value of 1 in the range is 7. 2 might map to 2. So there 2 is the associated value of 2, and 3 might map to 8. Now, why? Well, first of all, we want to think, is this a function or not? And this one's not a function. And if we go back to our definition, why not? Well, if we look at the first one, it says every value in the domain must have an associated value in the range. So if we go back, 4 does not have an associated value in the range. And so this is not a function. How about if I was to draw another one where, and let's say in this one we'll give 4 a value in the range. So here's my range, so I'm going to stick with my same domain and range. So, and let's say 1 can map to 7, 2 maps to 2, 3 maps to 8, but let's say 4 maps to 8 as well. This is a function because now every value has a value in the range. Every value in the domain has a value in the range. Now, if we then do one more example with this idea of mapping, so here's my domain again, and then the range. And 1 went to 7, 2 went to 2, 3 went to 8, and we said 4 went to 8. But let's also say that 4 went to 2. Now this is not a function because now 4 has 2 values in the range. And so that means that again we contradict the second rule for a function. So because 4 has 2 associated values or 2 images in the range, it's not a function. Okay, alright, let's look at another example. Let's consider 1 on X. Now, if the domain was every real number, then this would be not a function. Why not? Well, x equals 0 would have no value in the range. Or another way of saying that is no image. Remember, image is the output value for a particular input value or domain value. So what we do is we change the domain so it is a function. Now x is the only value, 0 is the only value that 1 on X doesn't have a range value for. So we change the domain to be X in the reals, but X not equal to 0. Now, just one thing with notation, I probably shouldn't write domain equals. That's kind of poor notation, so I'll instead write domain with a colon, like that. Okay. Example 4, we're going to look at some graphs. And we're going to use what's called the vertical line test. So, for example, if I go back to my graph that I had originally, here it is. So it could be something like that. Now, if I draw a vertical line, it has to intersect the graph once and only once. So if I draw a vertical line here, we can see that that doesn't happen. It intersects the graph here, here, and here. So the one x value has 3 y values, or range values, or outputs, or images. So this is not a function, because the one x value has 3 y values. If I drew another function, let's say it looks a bit more like this. So I've got a horizontal line going across there, and it doesn't exist at the final point. And I draw another bit where it doesn't exist at the initial point. If I draw a vertical line here, then that doesn't intersect the graph at all. And so if we were to take all of the x values as my domain, so if x is in all real numbers, then this is not a function. And that is because it does not intersect the graph at this point. Okay, alright. So here's an example from the textbook. So determine, giving reasons, which are the functions, or rather which are the relations of functions. For those that are, write down the domain and range. Well, if I look at the first one, we can see that all those x values are different. So there aren't 2 points with the same x value and different y values. So this is a function. And its domain, well, its domain is just all the x values. So that's -2, -3, -4, and 0. And then the range is all the y values. So that's 0, 3, and 8. Note that it's fine for a point to have the same y coordinates and be a function. It's not fine for it to have the same x coordinate and be a function. The second one though, if we look carefully, 2 of the points have the same x coordinate and have a different y coordinate, which means that an x value is mapping to 2 different y coordinates. So this is not a function. The third one, well, that's a straight line. So if we think about a straight line first of all, something like that. Well, all of these y values, or all of these x values, have only one particular y value associated with them. So this is a function. Now a line exists forever. It goes on forever, up and down and left and right. So the domain is all the real numbers, and the range is all the real numbers. For number d, y squared equals x. Well, if we think about it carefully, if y equals -2, then -2 squared is equal to 4. And if y is equal to 2, then 2 squared equals 4. And so 4 is the x value, so x equals 4 has 2 y values, -2 and 2. So this is not a function.